I was curious to find out how CFLs work, so I opened one up and found an electronic ballast inside. You can see how small this one is, thanks to the invention of Edward E. Hammer in 1976 in response to the oil crisis of 1973. Compact fluorescent lamps is similar to the linear fluorescent lamps. The tube is just folded up and is made to take up space and incandescent light bulb wood. You see that there is a seam around, and you can pry it apart using suitable tools. Just be cautious that you do not break the glass, as it contains mercury vapor which is hazardous and the phosphorescent coating could be potentially dangerous. The CFL has three parts: the base, the electronic ballast, and the glass tube which is phosphor coated. The base has two metal plates to which the phase and the neutral leads from the electronic ballast are connected. Electrolytic capacitors, non-electrolytic capacitors, a transformer, MOSFET, toroidal inductor or toroidal transformer, a serial capacitor, different diodes, and a thermistor. And resistors. This is an electronic ballast from a linear lamp. The electronic ballast from the linear lamp is very much similar to the ballast from the CFL. You can see the different components present like the electrolytic capacitors, non-electrolytic capacitors, MOSFETs, toroidal inductor, a transformer, different diodes, and many resistors on the back. Diode is a semiconductor device that allows current flow only in a single direction, that is the forward direction, and blocks any current flow in the reverse direction. So there is no reverse current at all. Here's a thermistor. The word thermistor is a portmanteau of the words thermal and resistor. Their function is to exhibit resistance on subject to the corresponding temperature change. There are two types, the NTC thermistor and the PTC thermistor. The negative temperature coefficient thermistors exhibit decrease in resistance with increase in temperature, whereas the positive temperature coefficient thermistors exhibit increase in resistance with increase in temperature. This is a MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. It is basically a transistor. Transistors are used in mobile phones, laptops, wherever integrated circuits are used. Transistors work like switches but without any moving parts. They are also used to amplify the electric signals. An inductor is just a coil of wire that temporarily stores energy in the magnetic fields it produces. The current always lags in an inductor and can never change instantly. Capacitors store energy in the electric fields that are produced between the two metal plates. Smoothing capacitors are used to smooth out fluctuating and erratic voltage signals. They are used along with rectifiers to supply smooth DC voltage. Here's a transformer from a battery recharger, and this one's from a mobile recharger. A transformer is a device that steps up or steps down the voltage. It basically consists of a laminated magnetic core over which there is a copper winding. The basic principle involved in a transformer is electromagnetic induction. A transformer consists of a laminated magnetic core, a primary coil and a secondary coil. When current flows through a wire, magnetic fields are produced around it. Similarly, when alternating current flows through a primary coil, alternating magnetic fields are produced, and the secondary coil is effectively linked to the primary coil through the core due to electromagnetic induction. As the EMF per turn in the primary and the secondary is same, increasing the number of turns in the secondary steps up the voltage and decreasing the number of turns in the secondary steps down the voltage. A half-wave rectifier is a circuit which rectifies half of the AC wave. It consists of a single diode in series with a load resistance in the secondary circuit of the transformer. As the input is AC, it reverses its direction after every half cycle. During the positive half cycle, the current flows through the diode as the diode is forward biased and through the load resistance. But during the negative half cycle, it encounters the diode to be in the reverse direction, that is, it is reverse biased and therefore the current will not flow through it. And hence only half of the AC wave is rectified and pulsating DC voltage is produced. Rectifier is a circuit which rectifies both the half cycles of an AC waveform. It can be constructed either by using a center tap transformer or a bridge rectifier. Here's a center tap transformer using two diodes. During the positive half cycle, the diode 1 is forward biased and D2 is reverse biased. So current flows through the diode 1 and through the load resistance. During the negative half cycle, the diode 1 is reverse biased and D2 is forward. So current flows through the diode 2 and through the load resistance. So both the half cycles are rectified and the wave rectified due to diode 1, due to diode 2, this one is due to D1, D2. So a pulsating DC voltage is produced. In electronic ballasts, however, we do not use center tap transformers as they are expensive to produce, and we use bridge rectifiers instead as they are cheap and easy to produce.
Okay, sir. Okay, sir.
A bridge rectifier is 4 diodes connected in bridge configuration. It converts the input AC voltage to pulsating DC voltage. The transformer secondary is connected to diametrically opposite points and the load resistance is connected to the other 2 points. During the first half cycle, the upper end of the transformer secondary is positive with respect to the lower end. During this time, the diodes 1 and diode 2 are forward biased and D3 and D4 are reverse biased. So current flows through D1 and to the load resistance. From there, it flows back to the source through diode 2. Current will not flow through D3 and D4 as it is reverse biased. During the second half cycle, the lower end of the transformer secondary is positive with respect to the upper end and diodes D3 and D4 are forward biased and D1 and D2 are reverse biased. So current flows through D4 to the load resistance and flows back to the source through D3. Notice that during both the half cycles, the current is flowing in a single direction through the load resistance. That is, the bridge rectifier converts the AC to DC. The electronic ballast circuit diagram includes the AC line input voltage, an EMI filter, a bridge rectifier, a smoothing capacitor, a control IC and a half bridge resonant output. The lamp requires a high frequency AC current during running. So the IGBTs come to our rescue. Insulated gate bipolar transistors switch the DC current on and off at a very high frequency of about 20,000 to 40,000 Hz, therefore eliminating the flicker problem. So how do you convert this AC to DC? Well, what you do is take a bridge rectifier and a smoothing capacitor. The bridge rectifier fully rectifies the AC voltage to pulsating DC voltage, and the smoothing capacitor is used so that the pulsating DC voltage can be filtered off the ripples and a smooth DC voltage is produced which can be supplied to the IGBTs. Once the lamp starts, the voltage rapidly increases, initiating the gas discharge process instantaneously. It is the control unit of the ballast that regulates the voltage and the current flow. The electronic ballast decreases the voltage, therefore increasing the current. The thermally emitted electrons during the preheat stage now strike the mercury vapor atoms and excite them to higher levels. So when these electrons fall from the higher energy levels to the ground level, they release energy in the form of photons which falls in the ultraviolet range. The phosphorescent coating then converts this UV light into visible light which is harmless.